Hey everyone, Matt from Workshop Thinkers here. Fun one today. I have these retrofit LED lamps. This one's dead. I'm rather peeved because it's less than a year old. So I want to see if I can fix it. If not, I mean, they're not expensive, but it's still annoying. So how it works is it is an Edison bulb type connection. It's just plug in. It goes in the 6-inch, actually I think this one does 4 or 6-inch can lights. You know, that goes up in the ceiling of a lot of places. I've just got it in my basement. Let's see if I can. That's worthless. Let's use a screwdriver. Looks to me like it is just a tab, but it's not coming out. Man, these things get dirty so fast. A little bit smaller of a screwdriver. Nope, that's not a flathead. I don't have a smaller good flathead. Are these flatheads? No, they're not. Worthless. This is not going to work. I'll give her a try. Wow. You really don't. Alright, back in a minute. Alright, well, apparently you go in through the front, and this was just glued on. Still in one piece. I didn't scratch it up too bad. If I had to glue it back in, I have to glue it back in. No big deal. Let's try to pop this out from the correct direction this time. Sorry, I'm trying to get this where you can see it, but I'm used to popping these things against my belly. My big old belly. That was busted. And wow, still does not want to come out. What do we see here? DLA6810-A 27, 30, 40, 50, 65. I'm assuming those are voltages. Ooh, 65 volts. That looks like the power connection there. I don't see any other circuitry on here, so I'm assuming there's still a power supply in the back. Wow, this thing, I wonder if it's glued on as well as snapped in place. It is not coming for any gosh darn reason. Oh, okay, so this one's completely broken. That one, if it's not broken, it's darn close. Wow. Just let's go for unreasonable force, how about? Well, let's keep working our way around. Thankfully I have a bunch of flatheads. Yikes. Wow. Pete's sake. Okay. Okay, think I can... Well, too late now. I was going to ask if you thought I could pull it out, but it's out. I hope you're seeing this, but I am not having a good time at this right now. This feels like it's way more difficult than it should be. See what I'm seeing? That's where... Okay, so I got two tabs. They're not latched in here anymore. It's still not even pretending to come out. I do see circuits in there. Alright, number 3. Maybe I should take out those screws. Watch, it'll just kind of pop and the whole thing comes out. Oh, for Pete's sake. All right. What do we see here? Oh, that screw's gone. You saw that, right? All right, what do we got? What do we got here? That's easy. Transformer. Capacitor, 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 capacitor. I'm assuming the resistor. I'm not familiar with what these are. Are they inductors? They're labeled L1 and L2. Capacitor, capacitor, capacitor. There is not going on here. And a CS4N60 source drain gate, so that's probably a transistor. Oh, I see. Oh, that doesn't look fun. So the only separation I see is right there. The 1, 2, 3, 4. The transformer has 4 pins. 1, 2, 3, and I'm not seeing the 4. It should be. Oh, it might be part of that diode there. Yeah, I think it is. Is there 4? Oh, there might be only 3 pins. That's fun. Well, this got a lot more difficult, as this is probably beyond my skill set. Well, I'm almost guaranteeing it's beyond my skill set. Give me 1 second. I'll be right back. Alright, some basic troubleshooting. Buying a light. Okay, it's on. If you're not comfortable with this, don't do this at home. That's all I can really say. I'm comfortable. I've been shocked by 210. Okay. Or 120. Way too many times. Okay, so this cable's good. Always start at the source. Move from there. It's just how I've been taught, how I like doing it. Next thing LED I'd expect to be DC, so I'm going to change to DC, turn this back on, make sure, yeah, it's still dead, and I expect this to have diddly, as I was expecting. Back to AC. Okay, just like to check that. Okay, we have a, I can't see that. That resistor looks FR1. I should know what that means. I can't remember what it means. Resistance. Wow, I'm getting readings all over. Okay, 10.3 ohms. That is, can you see that? Brown, black, black, gold. Brown is 1 and 2 zeros. Is that right? Brown. Brown is 1. No, I'm wrong. 1 0 and is in 1 1. No, hold on. Resistor color code. Images. Brown 1 0 and 0. So that should be 1 ohm. Good. Still 10 ohm. Let's make sure. Brown, black, black. 1 0 0 zeros. So that should be 10. No, should be 1. I could be wrong. I could be forgetting how to do this. Let's go with 10. Should be good. So theoretically, I know this will have nothing out of it. I know a bunch of safety Nancy's were not going to like this. Plop. Schling. Back to volts. That is right. Put that out of the way. This is live right now, just so everyone is absolutely clear. $220. Okay, so let's turn this off and figure out what is next we have to look at. It goes into here. That looks like a bridge rectifier. I can't quite see it. 10 S10. We got source. Yeah. So the other end. So this should be 120 volts in on this side and 120 volts DC out on that side. Let's give her a check. I don't see anything that's dead, so component by component through the circuit. And no, I can't draw it. Ow! Okay, something live is over here, so I'm just going to go straight to might be the diode. Nope. It is something 120 at that resistor. 120 here. Not 126 volts. Something right here. 120. Other side of that resistor. 120. No, 5. 6. 10. This resistor shot. Let's check that again. make sure I'm following it through right. Oh, it's this thing that's screwing me up. That is discharge resistor and capacitor. Crud, that's going to screw me up. Because it goes to this resistor, which goes straight across. This resistor also goes to this other thing, which goes through to down here. If this is right, this should always be neutral, but you can't trust that. It could be wired backwards. So what it's using is this neutral here. It should be universal neutral. Yeah, so these resistors on the other side of these capacitors, these must be a weird looking capacitor. They're 2.0, whatever that means. 2.0 microhenries is for little winding thingies. Lost the name of it. Capacitors are, I can't remember the name, what system and unit it uses. Anyways, moving on. So we'll get weird through here because the capacitor should be just a smoothing. So that capacitor could be gone. If that's it, that'd make things a lot easier on me. Just because inrush, this is FR. I think that's the one that gets hot and it shunts, or the resistance goes up. You know, it looks like it's been getting hot. It's been doing something there. But this capacitor here, let's check it. So what I'm going to do is check across this one here. Oh no, it is farad, and it's got an F there. Check that one, and I'm also going to check this one. This one gives me nothing. Maybe I have it backwards. Hold on. 12.55 nanofarad. Try that again. It's thinking. Overload. Great. Let's try down here. So either something in the circuit's messing it up. I don't think that resistor will mess up. It might be. Yeah, I got nothing there. Should just be smoothing. So in theory, oh, by the way, I found out this just drops out. Negative to positive. No, negative to negative. I'm just going to have this hold it here. I think if I get a little doojubajoo to jump across that. Hold on. Do jump across, this might light up, which, I mean, I'm not putting it back into use if this is true, but this is either going to make things go good or smoke it, or possibly both. You know, light it briefly for a second. Why can I not get this thing to open the jaws? You've betrayed me, alligator clips. Betrayal. Go figure. Okay. Bad capacitor. Bad smoothing capacitor. See, even those of us who can't do circuit design, as long as you have a basic understanding, can still figure out what's wrong. Now, the tricky part is, can I just replace that capacitor and everything be fun, or is that very specific? Let me think on it. I might just try to swap that out. If I do, I'll bring you back. If not, well, I'll do an outro. Doesn't matter. Alright, so 99% sure this is the culprit right here, because when I shorted this, it turned on. And this is for the supply side. I thought it was a smoothing conductor, but I was curious because, as you can see there, the circuit board says L2. The other one that looks identical is L1, but the capacitors are labeled C. So labeling what I know for a fact capacitors, these two big chunky ones, these small square ones, and these little gray ones on the back, if that's capacitors, what's L? Turns out it's coil. Inductor. That's what uses microhenries to measure. It's the other thing I was trying to remember. I don't have any of these, I can tell you right now. The reason why I didn't recognize it, and so everyone else who might not be as well versed as I, is because I'm used to seeing them in that or that. See that little coil back there? That, or that coil right there. See the wire around a ferrite core? That's what I'm used to seeing. And actually looking at that one versus this one, they're close. Dip this in some ceramic or some other epoxy, whatever they use to coat this stuff. That could be very, very close. Obviously, I've already decided I'm not fixing this light. It's not going back in the ceiling. Any fix I do, I don't trust. I don't want it to go back in my ceiling, catch fire, and burn down my house. That's just stupid. $15, $20, whatever. My family's health is more important than that. This is a curiosity. I was just trying to see if I could fix it. And I figured out what was busted. You're supposed to get some sort of voltage to the bridge rectifier there, the rectifier, and I wasn't. And the reason why I knew it was a rectifier, let me put down this power supply so it's out of my hands. A couple reasons. One, tracing the circuit board from these to the power inlet there. Let me pull this off so it's a little easier to see. From this power inlet, one goes here to this leg, as well as the resistor, and the other one makes its way to the other leg. And now if you look very, very closely, which I'm not sure you'll be able to see, I can see it though if I hold it just right, the other two are labeled plus and minus. Okay, AC in, DC out. Actually, it's labeled really well on the circuit board, but the chip itself is also labeled. So that's a bridge rectifier. Nice and easy. And as you saw, my troubleshooting steps was literally start at power in and start checking components. And I, due to my lack of knowledge of circuit boards, generally I'm okay with getting hit with 120 through one arm. Through both arms is a little dangerous across the heart. Don't like that, but I've been hit so many times just wiring things when I should have turned off the power and haven't. I'm a little less safety conscious. And I know I'm going to get a comment about it down in the comments. I don't care. But anyways, got to that point and didn't get any further. Bridge out that where the coil used to be. It worked. One thing I'm going to do before I'm completely done is I'm going to put a jumper across those two spots again, get this on. I want to know what kind of voltage out. So just because I want to use this chip some more. And once again, someone smarter than me will be able to say, oh, there's 10 diodes here, LEDs. The forward voltage is blah blah blah. They're in, just looking, it looks like parallel, inside ring, outside ring. Is it? Yeah, it's parallel. So they're all in parallel, which means the voltage goes up instead of amperage goes up, I think. Hold on. No, amperage goes up, voltage stays the same. That could be a 12. Well, the chip says 94 volts. See the silk screening there? It says 94 volts. If it's 94 volts, wow. I don't know. I might have a driver I can use for this. I might not. I'm not sure. Easy way to find out, though. No, you don't get a watch. Anyways, remember, even if you aren't great at this type of thing, you don't know exactly what you're doing, don't let that stop you. Feel free and see what you can see. Just know that your lack of knowledge does mean safety comes into a factor. If you don't know enough to be safe, don't do it, please. I know that the most I was going to get out of this was 120 or so. Capacitor could give me a bit of a shock, but it was, what's its rating up to? 80 volts at 150 microfarads. Whatever. I don't care that much. That one's 25 volts. And what I got shocked off earlier was one of these capacitors were still charged. Anyway, doink, and went up my arm. The coil here, the transformer is odd. It's using a common for both coils, as far as I can tell, both windings. Because I only see, I'm looking down through, I'm only seeing 3 wires, unless I'm missing one. 1, 2, 3. So I'm pretty sure there's 2 coils using a common ground. Way over my head. Anyways, this was fun little circuit. Don't know how exactly it works. There's controls and brains and stuff, but basically what happens is put in power at the correct voltage, out comes the correct voltage out. This might be a current regulated, so they can use the same chip on a number of different wattages, quote unquote, of these, and just swap them out for different ones, different ratings. It's got a lot of components. It looks relatively well built, but that coil killed it. Anyways, thanks everyone so much for watching. Keep tinkering. See you next one. Hopefully I'll be back to 3D printer shortly.